As I told you before, the capacity region of the broadcast channel is not known. But the best achievable region is Marton's bound here. So Marton's achievable region is due to Marton. And what she did, she used superposition coding and together with binning. So in principle, we do the same construction as we did for superposition coding, but now we do it with two satellites and we do it with binning. So the code construction is as one expected. We consider a distribution PT U1, U2, and a function that maps symbols T times U1 times U2 to symbols in X. So first we generate code words 2 to the n R0 code words Tn of W0 from 1, 2 to 2 to the n R0 by using the distribution T. So next, this is for the common messages. Next, for every Tn of W, use code construction in the section where we introduce binning. Thus we generate 2 to the n R1 plus R1 prime code words, UN1 depending on W0 and W1 and V1. So W1 goes from 1 to 2 to the n R1 and V1 goes from 1 to 2 to the n R1 prime. This is the size of the bin. By choosing the symbols U1, I of W, W1, V1 independent by using the distribution of U1 conditional on T. In the same way, we generate 2 to the n R2 plus R2 prime code words, U2 to the n of W0, W2, and V2, where W2 goes from 1 to 2 to the n R2, V2 goes from 1 to 2 to the n R2, this is the size of the second bin, and by using PU2 under the condition T. So you see, here we use, again, the common message as somehow as the center of the cloud. And the bins is somehow the stack code words, but code books, but now with bin for the first dedicated message, and we do the same for the second dedicated message. Now what did the encoder do? So he gets some W0, some W1, and some WU2. First thing, he tried to find a pair V1 and V2 such that Tn of W0, U1n of W0, W1, V1 tilde, and U2n of W0, W2, V2 tilde is jointly typical to the joint distribution of T, U1 and U2. And if there is one, then we choose some V1 tilde and V2 tilde as V1 and V2 and transmit Xn, and then we use the function of Tn W0, U1 to the n and U2 to the n and transmit it over the channel. That's exactly like we did before. We have here this W0. This W0 acts as a cloud center for the first dedicated message and as cloud center for the second dedicated message, and additionally we do binning. Now what did the decoder do? Also as expected somehow. So the decoder 1 received Y1 to the n, and he tried to find the triple W0 tilde, W1 tilde, and V1 tilde, such that Tn of W0 tilde, U1 to the n of W0 tilde, and W1 tilde, and V1 tilde, and Y1 to the n is jointly typical to the joint distribution of TU1 and Y1. If there's such a triple, then we choose one and put out the corresponding W0 tilde and W1 tilde as the estimate of the common message and the estimate of the dedicated message. If there's no such pair, then we assume there's an error and we just put out 1, 1. And the decoder to do the same thing, we have just replaced the 1 by a 2 everywhere. So you see that's more or less the generalized superposition coding and together with binning. And this gives you really the achievable region. We don't go through the analysis of the strategy, but I think you all will be able to do this because we have done all the things already. But if you do this, as a result, you will get something like this. You get that R1 prime plus R2 prime must be bigger than the mutual information of U1, U2 under the condition T. Then you get that R1 plus R1 prime must be smaller than the mutual information of U1, Y1 under the condition T. And the triple R0 plus R1 plus R1 prime must be smaller than the mutual information of TU1 and Y1. And R2 plus R2 prime must be smaller than the mutual information of U2, Y2 under the condition T. And finally, R0 plus R2 plus R2 prime must be smaller than the mutual information of the joint distribution T, U2, and Y2. I think you see somehow the result we have before, because we don't have binning, so you can put this together. Here is also when we don't have binning, so all these prime things disappeared, and also here some condition disappeared. But now let's assume we have this, and somehow we want to get rid of the size of the bins. So therefore we can form it to this rate bound here. So just by putting these equations here together. So that means Marton showed that we can take the closure of the union of all PTU1, U2, which we can choose before, and all functions which we can choose, of the rate satisfying these equations here. And the resulting region is the Marton achievable rate region. And this is the best region known today. For some special channels, it's already shown that for some special cases, there are other points which are better than Marton.